Hello again. We're continuing with our gateway questions, number 32. This is what you're expecting here is to see another chain rule because the questions 31 through 40 are supposed to be chain rule questions. I'm looking at this one though. I see, there's a fraction going on in there, and I wonder if I should use a quotient rule or not. Here's the thing. True, it's a fraction, but I'm looking at the numerator of it, and it's a constant in the numerator. It's easier if I treat this as a negative exponent and treat the denominator as a negative exponent and bring it to the top and use a chain rule only. So yes, you can use a quotient rule and a chain rule. It makes it more complicated. So skip the chain rule, skip the quotient rule and just use the chain rule. So how do we use the chain rule? Chain rule, there should be an outer and inner function. So u of t, I'm rewriting u of t with the form that is obviously inner and outer. Again, when taking derivative, I do not like radicals. I replace them by exponents most times. In here, I'm gonna replace this. It's an exponent to power 1/2 in the denominator. I'm going to bring it to the top, so it would be exponent negative 1/2. Outer function, which is to power negative 1/2, and inner function, that is t squared plus 2t minus 1. So now taking the derivative of this composition, outer function to power negative 1/2, inner function t squared plus 2t minus 1. The chain rule in Leibniz notation here tells me I'm supposed to take the derivative of the outer function with respect to inner times the derivative of inner function with respect to the variable I'm taking the derivative with respect to. That is, in here, this is going to be b. The outer is just b to power negative 1/2. And so I'm taking the derivative. It's like taking peeling the layers of the onion, taking the derivative of the outer, negative 1/2 comes down, a general power rule. This entire thing to power 1 less, this is dA over dB. That's derivative of A respect to B. Negative 3/2. Negative 1/2 minus 1 is negative 3/2, and unchanged inside function, b is unchanged, and then multiply by derivative of inside. Derivative of inside is derivative of b with respect to t in here. Which is 2t plus 2 plus 0. You don't need to simplify any of this. You can enter this in the in WebAssign and we'll accept it. Important part is that to power does not distribute in here again. The other important part is to recognize that the outer functions and the inner functions, and when you're peeling the onions, you're taking the derivative of outer function, make the inner function unchanged, then you have a chance to take the derivative of inner function, and that's a separate part of it. So, continuing with the same problem, I want you to notice that this, when you are taking derivative of the outer layer, this is called the dA dB, and then the derivative of inner layer is dB dt. The outer layer is b raised to power negative 1/2. And we're done.